SwayamPrabha. Digital India. Educated India.
Welcome back. In lecture 3, we will continue with our earlier lecture on planning strategies. We have already covered the concepts why we need urban utilities and infrastructure planning. We have talked about the different design periods for different for utilities infrastructure. We have talked about population forecast, some of the methods of population forecast, and in this particular lecture, we will start from land use forecast. Similar to population forecasting, we also need to do land use forecast, and as you know that land use is the purpose the land serves or the different activities that are carried out in them, such as residential, commercial, recreation, and land cover is the surface cover on the ground like water bodies, natural vegetation, what kind of rocks and soils are there, the artificial cover is there. So this land use and land cover, both of them gradually transform over time, and usually we need to keep a track of how this transformation is taking place, and based on this particular history and background of urban growth, urban planners actually decide what to retain or which part of the growth is sustainable or it's good, what part they need to intervene and make some changes, and also how to plan for the new development so that the future development is more sustainable, more appropriate. So that is all about land use and land cover planning. So that's basically the change in an urban area or how the different parts of the land in an urban area changes in terms of the land cover, like for example vegetation, is it increasing or decreasing, or artificial cover of our area increasing or decreasing. These are important to determine maybe future runoffs, future other hydrology, like what are the recharge areas that are there in this particular urban landscape. So all these things actually plays a role in the land cover, plays a role in determining the hydrology of a particular area. Similarly, land use determines what kind of activities will be there, how many people will be staying there, what kind of residential land use, where it will come, and all these things will be predicted by land use. Usually we have got these development plans, there are existing plans and then there are proposed plans for a particular area. Area development plans, these are more detailed plans for a particular area where infrastructure layouts and all these things are specified. Then project specific detailed project reports, like then you take a particular project, then you take the detailed specifications. So there are different levels of plans which are available for a particular area, which actually helps us to decide on how we are going to plan for the utilities for a particular area. So if we have a proposed development plan and we know that these are the new areas where government is targeting to increase the city or expand the city, obviously have to provide some amount of utilities infrastructure over there that will encourage people to move into those particular areas. So this is how land use forecasting is related with infrastructure planning or utilities planning. So two more concepts which are very, very important. One is the carrying capacity of an area, and the other is the FSI or the floor area ratio of for any of the land uses for a particular area. So what is carrying capacity? Carrying capacity of an urban area, it can be defined as the maximum number of people that can be supported by that area, and this is based on many, many factors. And one of these factors, of course, it is based on the levels of congestion, that is road infrastructure, overall infrastructure capacity, institutional capacity, environmental capacity, sustainable capacity levels. So infrastructure capacity is there. That means if the infrastructure is not adequate there, I cannot say that this area would be able to carry more people. So I will not design policies where it will attract more people to this particular area, or we will not plan that certain amount of FSI or floor area increase will happen in that particular area. So this carrying capacity is a very important concept in urban planning, and infrastructure provision or infrastructure availability is directly related with carrying capacity of an urban area. So, infrastructure capacity determines what sort of carrying capacity? Carrying capacity determines the land use, and land use determines what amount of population it can support, and or what amount of population would be there in future, which even is again is connected with infrastructure capacity. FSI floor area ratio is another issue. That means how much amount of development I will propose in a particular area, or rather the intensity of development for that area. This is again based on the width of streets. The FSI is primarily based on the width of streets, adjacent streets, present and future traffic load, parking availability, land use of that particular locality, and utilities and infrastructure. So, if we have not adequate utilities, infrastructure is not there, we cannot increase the FAR. Why? Because more FAR means more number of people would be densely packed in a particular area. So, if I increase FAR from maybe 2 to 4, that means obviously I will build 4 times more in the same amount of space, right. So, that means 4 times more. So, at least from 2 to 4 means we will double the population for that particular area. Is the infrastructure has the capacity to supply that amount of demand of water or maybe sewage, or is there enough space to provide new infrastructure line, even though we may have the finances, but physically it may not be possible. So, all these things are related. So, infrastructure, utilities and infrastructure is directly related with carrying capacity and the FSI or floor area that we set for an urban area. So, how land use forecast happens? We determine the attractiveness of an area for a particular area. Like it could be a new area which the government wants to expand in, and once that attractiveness of the area is determined, the real estate developers or investors, they will actually start buying lands or plots over there, and then they will start trying to acquire certain areas and all, and this is the first step that happens. And once that step happens, within some of those plots and all, whenever the time is right, or suppose some new highway has come up or some new infrastructure has come up, real estate developers start developing real estate projects like residences, shopping malls and all in those particular areas. And once that happens, then people who lives in that area or people who are moving into that area from outside, they will start locating into that area. That means they will feel that, okay, there are new malls, there is new housing in this area is attractive, let's move into that area. So, they will decide to move or decide to go shopping if there is a shopping mall. So, all these things require infrastructure to support this. If you plan to move to an area, you will only move there if there is adequate infrastructure, or if that particular area is attractive enough. And then your decision to go shopping is also not directly related, but also you have to have toilets in the shopping mall with adequate water supply and so on, and you have to clean the shopping mall regularly. So, if you do not have those kind of things, you cannot have a nice shopping mall and people will not go there to shop, right. So, this location choices or decision to travel, this kind of choices are related with what kind of developments come up in that particular area. And this actual move is basically when people after they decide to locate, they actually move into that area. And when they do, then the density of that area changes, the carrying capacity of that area changes, right. The carrying capacity remains same, but actually the capacity that has been already covered will change. So, there is only remaining capacity, that is, you can only have a few more people who will come there. So, that also increases the price of that particular area and so on. So, this density changes, capacity changes, these are all related with infrastructure that is available. That actually if you want more people to move there, if you want the carrying capacity to be changed, we need to provide more infrastructure. And when we provide more infrastructure, it will become more attractive, the area will become more attractive, and then more people will try to acquire land over there, more people will try to construct there, and more people will come moving in. So, this is how land use forecasting also needs to be done. That is, these are events which happens all parallelly goes on, but again, if there is always a supply and demand difference, and based on that prices of that area will vary, and all this depends on the kind of infrastructure that is present. And along with road infrastructure, parking infrastructure, we also have water supply, sanitation, and other infrastructure, drainage infrastructure, which actually decides on the attractiveness of an area and the subsequent development of that area. So, that is why how land use forecasting is connected with infrastructure planning. So, in addition to population forecast and land use forecast, we also need to understand the different engineering design options, and there are two parts to it. One is the fundamentals and the other is the actual engineering design. Now, what does fundamentals refer to? Fundamentals refer to basic physical processes. First we have to understand those things. Whenever we are planning for infrastructure, we have to understand the fundamental background physical processes that happens, so that we can understand how to actually deal with that particular background process, what kind of infrastructure is to be provided to deal with that, and then we can decide on the best possible engineering design for that particular kind of infrastructure. So, how does groundwater flow in a particular area? Based on that, we can determine how much amount of water could be yielded from that particular well or particular deep tube well. So, amount of water available from deep tube well depends on how groundwater flows in a particular area. This is a physical process, and this is the actual water demand for a particular area. Principles of water and sewage treatment: how much can be reused? Based on what kind of sewage treatment you adopt, you can determine how much of that water could be reused. If the treatment is basic, then you cannot reuse the water. If the treatment is very thorough, in that case we can even reuse for uses where we can use it for certain purposes, which may be even sometimes it could be used for potable or other use within our residences itself. But otherwise, if it is partially treated, then we can use it for augmenting the green infrastructure or augmenting the sort of rich water bodies in that particular area, or recharge the water bodies in that area, or recharge some streams in that area. So, it depends on how much amount of treatment you give to the water. Based on that, we can actually use it for different purposes. Then we have got the engineering design, the design and technology options that are there for any kind of infrastructure, and we have to evaluate the different alternatives in terms of their cost, efficiency, performance, and so on, and then take a call on which is most appropriate for a particular area. So, these are the different aspects that needs to be thought of when we are planning for urban utilities. And in addition to that, there is one other dimension that is usually considered in most planning problems, but in utilities planning it is a little different. For example, for siting of infrastructure, where do we decide to construct or do a particular infrastructure? For example, where do we locate a overhead tank? Where do we locate a water treatment plant? Where do we locate a sewage treatment plant? So, selection of land areas for infrastructure as per the suitability to select the best option of land area. So, this is all about siting of infrastructure. That means, we select the land area which is most suitable for a particular infrastructure. And usually in case of utilities, this is very specific to the infrastructure that we are actually planning. So, that means, if we are planning for what intake points for water supply, then obviously it should be near the intake source, right. So, or if it is like a pump, then it should be basically either near to the overhead reservoir or near to the treatment unit or water treatment unit. So, there are a lot of technical criteria which decides on the location of infrastructure. But then what happens, if 2 or 3 sets of land or pieces of land satisfies all the technical requirements, then we need to take a call on which land to choose. Then other factors comes into play. What are these? These are land availability, land price, ecological and environmental impacts, affected population and biodiversity of that particular area, and so on. So, so these are the different ways we can determine out of all the different land options that are available, where we will actually site our infrastructure or a particular facility for that matters. So, first we have to make sure that all the design criteria for that particular infrastructure is met, then we can evaluate the best possible alternative. There are different ways to go about it, and again this is a lecture that you can actually follow to look into the different details of how we can actually determine this. This is applicable to all sorts of planning problems, this kind of evaluation. And there are 2 primary evaluations you can consider. One is the overlay mapping method and the other is the multi-criteria evaluation or multi-criteria decision making methods. So, these are the two ways we can go about it. So, the first method is, what we do is we prepare maps. That means we prepare maps based on, suppose, land availability. We first prepare a map for land availability for that particular infrastructure. Only the land parcels which are available would be marked. Then we take land price. So, we can again have, if based on land price we can create certain bands, and we can say higher bands and lower bands, and we can determine that okay, within this price range we will select. So, we can again reduce the number of choices. Then environmental and ecological impact. Each of these different kind of environmental and impacts could be actually again prepared into maps, and then we can find out which are the among the land those are available, and with a certain band of land price, which of them will have certain amount of environmental impact which is acceptable, and those are the ones we will consider. So, we will gradually reduce our options, and we would at the end we would be left with only maybe one or two options within which we will decide. So, or maybe we will be left with only one option at the end. So, the idea is we will use overlay mapping. That means we will map different layers of decisions or decision criteria, and we will select the one where all the criteria are fulfilled. So, only problem is the assumptions are there is independence among the criteria, because we are taking each layer or each criteria one after another. So, there is independently we are considering that, we are not taking them as a integrated measure. That means maybe one criteria is more, other criteria is less, we take a somewhere in the middle we take that. It is not like that. So, here all the criteria has to be fulfilled. The other is inappropriate standardization of the maps. That means each criteria will have different units and all those things. So, standardization will be different. So, again, this is the one way. The other, which is roughly like you create different layers of maps, we lay all the layers and see which are the common areas, and we decide on that particular area as a location. The other method is the multi-criteria evaluation or the multi-criteria decision making method, where we actually, there are several methods to that. So, it depends on multi-criteria technique and standardization methods, of course. So, the first technique is weighted linear combination, where we give a score to each of the options that are available to us, and what we do is we take a summation of the attribute weight and the attribute scaled value. So, for each attribute or each criteria based on which we are taking a decision, there is a score to it based on that particular plot of land for which we are considering, and then there is a weight to it. That means how important is that particular criteria. So, and once we have got all the criteria and all the weights, all the scores of each criteria and all the weights, we just multiply them and then add them up, sum it up, and we get an overall score for each option. Whichever has the highest score, we will choose that. So, this can be combined with a GIS overlay. GIS means maps could be created, and we can create maps based on which we can also do this particular decision. So, this is weighted linear combination, and we can also go for analytical hierarchy process. This is where we actually take the feedback of maybe experts or actually users or people who would be using that particular land. There, what we do is weights of factors and sub-factors are calculated using a preference scale and pairwise comparison metrics using opinion of experts of the affected population. So, we take two of those factors together, we compare between them, we take which one is preferred over another, and we take this we do this comparison among all the different criteria, and then based on that we can actually create the weights based on the opinion of experts and the population whoever we have asked for those pairwise comparisons, and then we can create those weights and determine, and then based on that weight we can determine the actual which option is the best one. So, same way, means weighted linear combination analytic hierarchy is more or less follows the same way, only in the first one the weight probably would be directly given by some expert or based on some cost parameter it could be determined, whereas in the second one weight is based on pairwise comparison. So, only thing changes is how we determine the weights. So, anyway, these are very common planning issues. So, in any place whenever we want to decide on which land area is suitable for something or for some purpose, this is the techniques that we can follow. Again, if you want to learn it in details, please go and follow this particular lecture. Finally, we come to the final aspect that we will discuss. in terms of utilities planning. This is called service level benchmarks. Service level benchmarks or standards, this is something which is actually required because this actually helps us to determine what is appropriate for a certain population. So that means what kind of services has to be provided. So this actually, because there are several service providers who will actually provide these services for the people, we actually has to create standards which that means everybody has to follow those standards, and because that standards should be designed in such a way so that they satisfy the people in terms of those in regards to those particular services. So this service level benchmarks, this benchmarking, the process is known as benchmarking, helps in performance management and increases accountability in service delivery. So these benchmarks are a way to measure the performance of utility or service providers to see if they are performing adequately, or if a particular urban local body is efficient, or this could be efficiency measures, this could be some performance measures based on which we actually can rate them, or we can compare different agencies, and accordingly we can take certain decisions. So this involves systemic measuring and monitoring of utility providers on a continuous basis. So this is primarily for as we are saying that implementation agencies is a big part, or operation maintenance is a big part in this. So this service level benchmarking is a part of that. That means certain if it's a private operator, it will only look into its own profit. It will not care about the provision of services or good quality services. So that is where the service level benchmarks are there, so that we will measure the performance of those particular providers and then take call on further funding, further investment, and so on. So this also helps in identification of performance gaps. So if we see that certain areas are not maintaining that, so there is a performance gap which we have to overcome, and this helps in identification and then sharing of information on best practices improves other utility providers. So if somebody does good, others will be able to know about it, and then they can perform better. So in India, Ministry of Urban Development, now Ministry of Housing and Urban Affairs, in 2009 they started the service level benchmarking initiative, and then they did it for water supply, wastewater, solid waste management, and stormwater drainage. And here they identified a minimum set of standard performance parameters for each of these particular service utilities. And so these parameters are very common ones, and this would be understood and used by all the different service providers. So nobody can complain that okay, this is not possible in our area. So these are basic criteria. And then they gave a framework for monitoring and reporting of these particular indicators. That means how each ULB has to report on their performance for each of these indicators. And then they also gave guidelines to operationalize this framework in different phases. So let us look at some of the indicators for water supply. You can see the list of indicators over here. This is like coverage of water supply connections, per capita supply of water, extent of metering of water connections, extent of non-revenue water, continuity of water supply. So these are different ways you can actually evaluate efficiency or performance of a service provider for a particular area. So the other things could be efficiency in redressal of customer complaints, efficiency in collection of water supply related charges. So this as we are discussing, utility planning involves the tariff setting, the actual operation maintenance part. It involves the customer complaints, so about service quality and so on. So all these things are part of the utilities planning. So these indicators also give you an extent about what are the different things that you need to improve for a particular service. Similar to water supply, this service level benchmarks will be discussed in detail in the subsequent lectures. Whenever we do the appropriate aspects, when we will cover water supply, we will discuss on service level benchmarks of that. When we do wastewater management, we will discuss on that. And you can see this list like stormwater drainage, coverage of stormwater drainage network, incidence of water logging. These are the two criteria. For wastewater management, many of the parameters same, like redressal of customer complaints, efficiency in collection of sewage related charges, then coverage of toilets, coverage of wastewater network services, collection of efficiency. So you see these are different parameters based on which we can evaluate service provision for a particular area. Now, how do we define the service level benchmarks? So, first of all, as I told you, these are the indicators that we have discussed. Now, let us take one indicator, coverage of water supply connections, right? So, you can see over here in this particular indicator coverage, first of all, there is a rationale to this particular indicator, why it is being considered. Then there is a definition, exactly what does coverage means in this particular case. Data requirement, what kind of data is required, the data quality, and finally the calculation. So, calculation is pretty easy, that is direct number of service connections divided by total number of households. That is percentage of households covered by this direct service connections. Data quality, the total number of households could be revealed by survey or each connection mapped to a number of households being served. So, there could be the data quality issues like how we are getting the data and so on. The data required total number of households with direct service connections. So, these are the two data requirements. So, as you can see that we also have a data reliability grading scale. If we are getting the data directly from service, it is a reliability of A, that is the best possible reliable data. If it is based on just average values based on geographical coverage or road lengths, that per road length how many connections are there. If we do based on certain average calculations, there is a C and D level of reliability. So, it is not only how we estimate a parameter, how we define the parameter, how we do the actual calculation, but also the data that we are using and the reliability of the data. These are important for service level benchmarks. And how do we use service level benchmarks? Service level benchmarks are used to determine or assess and evaluate performance of a particular service provider. So, the decision making level or the municipal council or the leadership actually assess the performance, and based on that they take decisions on policy, resource allocation, incentives or penalties for improving outcomes. So, ultimately they can either choose to award them or penalize them to improve the outcome. So, they can take both ways. That means sometimes we have to penalize a particular entity to make sure they work well, or we can give them a prize to motivate them. Then operational decisions and plans, based on this we have to create these plans, and then corrective actions and performance improvements has to be decided based on that. And then service improvements are done like this. We have to capture that particular data, and similarly we have to collate and analyze the performance indices based on our SLBs, and then this goes for reporting. So, this is a process in which decisions are taken in a municipal area. They first assess the performance of service, and then based on that corrective measures would be taken. But one thing important is, in India we are now using performance based grants. That means in addition to the normal grants, extra grants are given if a municipality is performing well. So, we see that performance based grants for the 14th this in 2016 and 20, different cities got different performance based grants, and you can see that in different states, of course, in Maharashtra got the highest performance based grant of 2483 rupees in crores, right. So, you can see that, and the least amount was got by Meghalaya, Sikkim, and of course, it depends on the size of the state and all these things, but probably this also reflects the performance of that particular state as well. So, this performance based grant is based on the performance report cards and sort of a system of award for this particular state, so that further improve, and using this the other states will also get motivated and they can also improve their services. So, now that we have learned about the different aspects of utilities planning, the final thing that we will talk about is the different data and service that are required. And as you understand, the utilities planning requires data from the social aspects, the physical aspects, then the engineering aspects. So, the data requirement is considerably large from other planning, and we require raw data, primary data, we require survey data, and we also require experimental data. And this secondary data, so this is the primary data that is required, and we can also get secondary data from published sources, maps, reports and regulations. And sometimes we can do when we want to get socioeconomic data, we can also go for user perception surveys, particularly for service quality, choices that they have got, or willingness to pay, how much amount of money they are willing to pay. For this detailed service, we will explain this in subsequent lectures, when as case study examples we will explain that. But if you want to again learn about details about how these surveys could be conducted, then you can look into these lectures which have been which you can just go to this particular links and you can study those particular lectures. Now, when we talk about this primary data, the raw data and the experimental data, so and also the secondary data, there are data has to be collected about different aspects. Now, not all this data would be required whenever we plan for either water supply or sanitation. Some subset of this data would be required, but these are the likely data sets that we require. For example, some basic data like regarding physical characteristics such as topographical details, slope of catchment, streams, canals, number of outfall points, intake points for water, outfall points for sewage. This data is required. Details of road network, railway network, bridges, culverts, railway crossing, these are required. Existing land use, land price, land cover, these are absolutely required. Then data on inflows from contiguous upper region, this inflow of water from the upper regions of catchment, how water flows from those regions to my area, that has to be understood. Then soil characteristics, which includes permeability, porosity, then runoff coefficients, soil bearing capacity. We will come during the course of our lectures, in the subsequent lectures, we will see that at different for different estimates, different calculations, we will require this kind of data, but it's better to have this data in hand ready whenever we start planning for this kind of infrastructure. Then groundwater tables along with the seasonal variations, rainwater harvesting, groundwater recharge structures in the landscape, solid waste and pollution sources. These are augmented by Survey of India topographical maps, satellite images, aerial photographs, and also the existing master plans, development plans and area development schemes for that particular area. So, data and other data and service includes rainfall characteristics data, rainfall data for 30 years or more, or data on historical flood events, and we require data on the rainfall intensity curves, number of rainy days, annual average daily and monthly rainfall. Based on that, we will estimate runoff and all this other water that is available for a particular area. Then we look into the waterway characteristics like capacity of water receiving body, high flood level, flow details in different season, size, slope, material and condition of water supply and water carriage networks, details of existing water bodies, natural and engineered drainage channels, tidal influences. So, these are all the different waterway characteristics also sometimes we require. And sometimes these are augmented by secondary sources such as location of underground utility trenches, maps on that, water supply and sewer lines in urban areas, watershed maps, location of pump houses, treatment plants and other infrastructures, the standards and benchmarks for that area. So, these are the different types of data that we actually collect when we want to go for, when we do infrastructure planning or utilities planning for a particular urban area. So, to conclude, utilities planning includes, in addition to planning part, the design options, the implementation of the project and its operation and maintenance. Land use and population forecasting is the basis of any utilities planning process, based on which both demand and supply of utilities and infrastructure is determined. Utilities planning is data intensive and the cost of data acquisition is also expensive. And benchmarking helps in performance management and increases accountability in service delivery. So, these are the references that you can study. Thank you.